So let's do number one of our challenge questions. It was actually much gnarlier than I expected. And I think there were some places where we got into trouble here. I think one place was a lot of students just quotient ruled this in place. And I don't love that. It would work. Um, I did a little bit of a min trick. I saw this y over x plus x over y is equal to -2 and was like, life would be easier if I wasn't doing two quotient rules or even bringing that x as a -1 power up. If I could just maybe multiply everything by xy. Let's clear those fractions before we even get started. If I'm going to do implicit, really doesn't matter where that implicit happens. I should make a note as I do this, though. All right, I'm going to distribute this to all of my terms. We end up with a y squared plus x squared is equal to -2xy. We would want to make like a little note off to the side because we cleared fractions that x doesn't equal 0 and y doesn't equal 0. Like this is the when we cleared those fractions, we cleared what were clearly some issues with restrictions on our x and y's because we couldn't have divided by 0. So anyways, now we can go ahead and take our derivative with respect to x. And this is going to be a heck of a lot easier than the quotient, though quotient would have worked. We have 2y dy dx plus 2x is equal to, get some product rule here, -2y plus, oh, I guess I'm going to end up with a minus anyway, so might as well get rid of it, 2x dy dx. All right. I didn't write that in the same order that we might have, but that's because I knew what was going to happen. We've done enough of those product rules and implicit to really know where we're headed. So again, I'm going to skip some steps here because we're in the challenge anyways. And I'm going to have that happen. 2x plus 2y, which means that I'm going to have over -2x minus 2y. All right. Now here's where I got in trouble when I did this problem. I was like hell-bent on just plugging this number in, the values, the -1 and the 1. And what happens if you do that is you end up with 0 over 0. And my brain just could not process that, like, maybe I didn't need to do all of that. But if you factor this, factor a 2 out of the numerator, factor a -2 out of the denominator, you end up finding you have that x plus y, x plus y. You have a fancy pants 1 there. So this is just equal to -1 for any value of x and y. Oh, how fun. All right, so there's our slope at all values of x and y. Now I'm really curious and want to see this graph and see how we have a graph where the derivative is always -1. But that's where we're at. So there we are, which also makes number two really easy because the derivative of a constant is 0. Oh, we didn't, number two is for the next one. So we can do that later. But I want to show you really quickly the quotient rule version. I haven't actually tried this on my own, so I probably will regret my life choices, but that's typical for me. So if we did this as a quotient rule, we have oh no, I'm already over it. Yeah, this is going to be horrible. Yeah, we're sitting there going, okay, and then low d high minus high. Oh, I made this a plus instead of a minus. Minus high d low all over low low. Ugh. Yeah, we'd have to combine that. Yeah, I'm already mad, so I'm done. I'm out. Out. I would have moved on to a different problem. So anyways, that was number one. I will make another video for number two, and then number three, and then number four.